Hi guys, this is Dr. Huan. Today we'll begin to introduce sequences, and we will begin with the basics of sequences. So a lot of those terminologies. Let's begin with consider this sequence. The so-called sequence is just a sequence of numbers. Oftentimes we use curly braces to represent this as a sequence. Now, each number in the sequence, that's called a term. So these are the terms of this sequence. Because, different sequences have different numbers. Oftentimes we would like to introduce some symbol, and here's the symbol, like we sometimes call this one as, this is the first one. Sometimes we call it A1. A means the first term of, A means the sequence, and 1 means the first term of the sequence. And of course, this we will call it A2, and this we will call it A3, and so on and so forth. So in this sequence, A1 is 2, A2 is 4, A3 is 8, and this will be the A6 in this case, right? Because it's the sixth term. Now I do want to make a quick comment here. So I'm gonna, do we have to begin with the A1? Not necessarily. So if you prefer, you can always call this, you can start with a different number, you can call it A0, and this is A1, then this is A2, and so on and so forth. So this is certainly legitimate. And you have to begin with 0 or 1, and again, not necessarily, you can begin with any number that you want, and you can start with, this is A4, then the next one will be A5, A6, and so on and so forth. So you definitely have the freedom to begin with the number that you prefer. So here here let's talk about index. So the index, this is called the index. The A1, the 1 is the index. A2, the 2 is the index. A3, 3 is the index, and so on and so forth. So for this sequence, the way we name the terms, the index starts with 1. If we name the first one as A4, the index starts with 4 and always increase by 1 and so on and so forth. Initial term, just by it literally, is just the first term. So the initial term is 2 in this case. Final term, in this case, is not applicable because, I'm going to delete that one, because usually we start with index 0, 1, usually that's most common. Now, the final term in this case, because this is a so-called infinite sequence, the ellipsis, that means it's never ending. We'll continue this pattern. So there's really no final term. But if I have a sequence that ends like this one, then this will be the final term. This is the initial term. Now, this is a infinite sequence because it never ends. And the next term is the explicit formula for the sequence, okay? Well, what is that? That means it is an expression so that you just tell me the index. I can find specifically what that term is. So for this particular one, if we begin with A1 being 2, A2 being 4, and so on and so forth, we see that to get to the next term, we just double the previous term, right? So 2 double it, you get 4. 4 double it, you get 8. 8 double it, you get the next one, and so on and so forth. So therefore, I'm going to call my an is going to be 2 to the power n, okay? Because it's just double from previous one, where n is greater than or equal to 1. This is called the explicit formula, one explicit formula for this sequence. And you can check when n is 1, which means A1, right? So check. So here let's check. When n is 1, your A1, because n is 1, 2 to the 1, which is 2. So it does match the initial term. When n is 2, A2 is going to be 2 squared, which is 4, basically double previous one. That's what it is. When n is 3, n3 is going to be 2 cubed, which is 8. So, and so on and so forth. We do see that this formula works. So what's the nice thing about an explicit formula? Now, without really listing the terms out, I can find any term that I want. If you say, hey, what is the 10th term? I really don't have to double until I get the 10th one, right? I can just quickly 2 to the 10th, like A10 is 2 to the 10, which is 1024. So I can quickly find that with an explicit formula. All right, so we are familiar with those ones. We are familiar with those terms. And next thing is, I want you guys to be able to, given an explicit formula, you can write the terms. You can find any term using that. So let's practice on writing the first 3 terms for this sequence and for this sequence. For the sequence that has this as explicit formula, and for the next sequence that has this explicit formula. Now, for the first sequence, it says index starts with 1. So you really want to begin with k start with 1. Okay, so now A1 is k is 1, so 1 over 1 plus 1. That's what the formula says. K is 1, 1 over 1 plus 1, which is 1/2. When k is 2, let's take a look at A2. The second term will be 2 over 2 plus 1, which is 2/3, right? When k is 3, and A3 is going to be 3 over 3 plus 1, which is 3/4. I guess that you probably see the pattern 1/2, 2/3, 3/4. The next one will be 4/5 and 5/6, and so on and so forth. Now let's take a look at the second one. Okay, here the index starts with 2, the I. It's not k. It starts I. Then you look at I. It uses I, the index I. When I is 2, so I starts with 2, right? Then my B2 is, so that will be your initial term now. So 2 minus 1 over 2. So 2 minus 1 over 2, which is 1/2. Now when I is 3, then B3 is equal to 3 minus 1 over 3. So 3 minus 1 over 3, which is 2/3. When when I is 4, then your B4 will be 4 minus 1 over 4, which is 3/4. And pattern continues. You probably notice that they actually produce both formulas produce the same numbers, right? So actually both produce this 1/2, 2/3, 3/4, and so on and so forth. So even though they have different explicit formulas, they do end up with the same sequence. So the point is, sometimes the explicit formula may look a little bit different. They could produce the same, they could represent the same sequence. Now the next is, so here we use apply explicit formula to find the terms. That is pretty easy, just like a function plugging in the value and then you get the outputs, right? The backwards sometimes can be a little tricky. So let's take a look at how we actually find explicit formula when you are given a sequence. We'll begin with some easy one and then we'll look at another a little more involved one. And in this book, there are different strategies to find explicit formula for sequences. So let's begin with this easy one. So here the first one is same value but alternating sign, basically. So you can just by a little trial and error, I'm gonna say AK equals. So I do see alternating sign, so therefore I'm going to introduce -1 to some certain power. So I'm gonna just this what power, let's to be determined, okay, and times the 2. Now it really depends on how you want your index to start with. So I'm gonna oftentimes, again, most often we start with 1. So I'm gonna just simply start with 1. And then if it is 1, let me look at the power now. The first, that means you want to call this as A1, this is A2, this is A3, and so on and so forth, right? That's how why you begin with 1, then this will happen. And all the odd number terms, they are odd, they are negative. So therefore, I'm going to simply just put a K there, okay? Put a K right there, because when it is odd, I get a negative term. So it seems like it perfectly match. And then we can check. When case 1, A1 is negative 1 to the power 1 times 2, which is negative 2, so it's good. When case 2, A2 is negative 1 square of the negative 1 becomes positive, and then times the 2, which is positive, and so on and so forth. So this will work. Now if you for some reason, some people may prefer, I don't want to begin with 1, I would like to begin with A0, and this is my A1, the next term is my A2. That's fine. You just need to do a little adjustment. In this case, your A, or you don't have to use K, you can use I. That's called a dummy variable. They won't affect anything. So AI is equal to negative 1 raised to, I'm going to say I plus 1 in this case, times the 2, where I is greater than or equal to 0. So let's check. When I is 0, that's what you begin with, A0. A0, I is 0, negative 1 raised to 0 plus 1, which is 1. So negative 1 raised to power 1 is negative 1. Negative 1 times 2, which is negative 2. So it's good. When I is 1, A1, which is the second term, I is 1, 1 plus 1 is 2, negative 1 squared, which is positive 1 times 2, which is 2. So therefore it works. Now they both produce the same sequence. So therefore either one will be correct. So my whole point is sometimes, again, they may look a little different. That's completely fine. That can happen. And also the I and K, that's so-called dummy variable. The index is dummy variable. You can use other letter that you like. Some people use N. So I, some people use J. Those I, J, K, N, M. Those are the popular letters for the index. Now the second one is, let's take a look at that 1/3 negative. By the way, we certainly see the alternating sign there. And then we see that the numerator matches 1, 2, 3, 4. It's just 1, 2, 3, 4. And the denominator is always 2 more than the numerator. So with that observation, I can say I'm going to try to use N in this case. AN is, so because it's alternating, I certainly want to begin with negative 1 raised to some power. And I actually, because I observed that all the odd terms, they are positive. All the even terms, they're negative. So I want to add 1 to here so that when n is odd, this actually becomes even, so that it's positive. So, and then here I do see that numerator matches the index, and the denominator is 2 more than the numerator. So therefore this is my explicit formula where n is greater than or equal to 1. Okay, so this is the second one. And the third one, 1/4, 2/9, and again the numerators, they just matches the 1, 2, 3, 4, it matches the index if I begin my index with 1. And the denominator, if you look at, these are perfect square. This is 2 square, this is 3 square, this is 4 square, 5 square. Seems like the square of the number, and that number is just 1 more than the numerator. So with that, do I have to use A? I don't have to use A. I can use B, Bn. Okay, and this is going to be n over n plus 1 square, where n is greater than or equal to 1. So these are the ones that pretty much we can just find an explicit formula just by observation. Let's take a look at the next one. So I want to use this one to show you a strategy sometimes for some sequence that's more involved, not as obvious as the ones that we've seen, a strategy that can be used. So first of all, you still have to try to find a pattern that you from these okay, from these numbers. And I do see that like 2, 6, you can add 4, right? From 6 to 12, you can add 6. From 12 to 20, you can add 8, and 10, and 12, and so on and so forth. I hope that you see that these are the even numbers. And because they're even numbers, I can think of this 4 as 2 times 3, 6 as 4 as 2 times 2, 6 is 2 times 3, this is 2 times 4, and this is 2 times 5, and so on and so forth. Now, again, that's the observation. Let's write the observation down here. I need a little more room, so I'm gonna move this to here so that I can get a little room to work with this problem. So here's what we observe. A1 is actually the 2, right? And what is A2? A2, if you add 4 to A1, then you get to A2, which is 6. So it's basically 2 plus, the 4 is 2 times 2. So I kind of rewrite the 4 as 2 times 2 because I see a pattern there. Now, how do you find A3? Basically, you just A2 plus the 6. So how do you find the A3, the 12? You add 6 to your second term, right? And this is, again, we just write, what is A2? A2 is this guy, 2 plus 2 times 2. That's coming from A2 coming from above. Plus the 6. What is 6? 6 is 2 times 3. 2 times 3. Now, I hope that at the moment I'm going to begin, I want to mention the strategy that I'm using. The trick is do not simplify. Just try to write as many terms as you can, but so that you can see a nice pattern. I feel like if I write one more, you probably see the pattern. Or you can pause the video and see if you can see a pattern now. When I say a pattern, that means like to find A4, without doing all this detailed step, can you, based on the pattern that you see, quickly write down what it's supposed to be? So now A4 is A3 plus 8, right? And what is A3? We just found the A3 right there. That's your A3. So therefore, I'm going to copy it down. And then plus the 8. 8 is 2 times 4. So I feel like probably at this point you see a strong pattern here. Without, I do see it. So the pattern is A5. Without doing any derivation, I know it's going to be this whole thing. 2 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. That's that. So 2 times 5, 2 times 4. You see a nice correlation there, right? Okay. So in other words, if once you see the trick is don't simplify. Simplify. You want to observe the pattern. That's the trick. So once you are able to find the pattern, let's talk about AN, okay? I hope that with the pattern you can see what is AN. AN should be 2 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus and so on and so forth. And what is the very last term? 2 times n. That's the pattern that we observe. Now let's try to find a explicit formula for this guy. So to find to find a formula for this guy, I'm going to factor out a 2 because I see 2 as a common factor. Then we have 1 plus 2 plus 3 plus 4 plus n. After you move out the 2, that's what we have. And fortunately, we have a formula for this guy, 1 plus 2 plus 3 plus 4 all the way up to n. This actually is equal to, so this guy is equal to n times n plus 1 over 2. In the future, we'll prove this result. Okay, we'll prove this result. And then we will cancel the 2, and therefore this is n times n plus 1. So, do you see that we found a explicit formula for an, which is n times n plus 1? So I'm going to write it here. an equals n times n plus 1. Please keep in mind you have to mention your index start with what number, right? So here my index starts with 1. Okay, that's what it is. You can always check. When n is 1, so 1 times 2, which is 2, good. When n is 2, the second term, 2 times 3, 2 plus 1 is 3, which is 6. When n is 3, so 3 times 3 plus 1 is 4, so 3 times 4 is 12. So you know this works. All right, this is the problem that I would like to share. I certainly want you to learn, get the experience on how to find explicit formula for a sequence. So again, the trick is sometimes do not simplify, observe it and observe the pattern. Okay.